Okay, so let's talk about nucleic acids. And nucleic acids are basically DNA or RNA. And if you look, DNA stands for deoxyribose nucleic acid. RNA stands for ribose nucleic acid. Yeah? Okay, cool. So basically, let's talk about the monomers. So the monomers for nucleic acids, it's called nucleotide. And a nucleotide is composed of a phosphate, a 5-carbon sugar, and a nitrogenous base. So this phosphate, just like in Chem, it's PO4 3 minus, or 3 minus, or 4 minus, O3 minus. Any one of those combinations is going to be a phosphate. Alright, now this 5-carbon sugar can be further subdivided into deoxyribose or ribose. Now, remember guys, the 5-carbon sugar in nucleotides, it is not considered a carbohydrate, despite the fact that we still like to call it sugars. So deoxyribose versus ribose are made up of a 5-carbon ring, okay, with a methyl group kind of sticking out. So this is 1', 2', 3', 4', 5'. Okay, again, 1', 2', 3', 4', 5' carbons. And just like the word suggests, ribose has an OH in its 2' carbon. Deoxyribose does not. So because it does not have an oxygen, it only has a hydrogen. This becomes very important later on when we're doing DNA replication, and we are using primers. Okay. All right. Now this right here is a nitrogenous base. Now, nitrogenous base. Now, nitrogenous bases can be further subdivided into DNA and RNA nitrogenous bases. The DNA one is CTGA, so CTGA, and the RNA one is CUGA. Okay, so instead of thymine, we have uracil. Okay, so this is what is used to go back and forth. Okay, so it's cytosine, thymine, guanine, adenine, cytosine, uracil, guanine, adenine. So anytime, every time you see uracil, automatically think RNA. Good? Alright, now remember, we can actually further subdivide these into more categories. C's and T's are pyrimidines. So this is how I kind of memorize it. City of pyramids. Okay, and pure as gold. Alright, so purines make up G's and A's. Pyrimidines make up C's and T's. The way you're supposed to memorize, the reason why you're supposed to memorize these is because later on when we're talking about Chargaff's rule, it's going to come in handy. Alright, so now let's talk about the DNA actual polymer molecule. So the polymer itself, it's phosphate, 5-carbon sugar, nitrogenous base. Okay, if you look at this, okay, now it's kind of upside down on the other hand. I know, you can flip your page if you do it. I've got a little bit more experience doing this than you do. Okay, cool. So, what I want you guys to see is this. This molecule right here is a nucleotide. This one right here is another nucleotide. Now, in between nucleotides, we have a covalent bond. And this covalent bond is called a phosphodiester bond. Okay. This is the phosphodiester bond. Good. So, if you look at the phosphodiester bond, it is actually connected between the 3' carbon and the 5' carbon on the other nucleotide. Do you see this? So it's 1', 2', 3', 4', 5'. So 1', 2', 3', 4', 5'. Do you see? Okay, this is why we say we read DNA from 5' to 3'. And then this is the opposite. Do you see? 5' to 3'. And so this is called anti-parallel. Good, good. Also, we have T's and A's being bonded to each other by hydrogen bonds. C's and G's being bonded to each other by hydrogen bonds. So remember, these are hydrogen bonds. They are not covalent bonds. So if they break apart, it doesn't mean that the chemistry of the DNA is changing. Okay? It just means that they are just unwinding, right? So there's also a way for you to kind of memorize this, and I memorize it like this. Tattoo. Please don't go and get one because I don't want to be responsible for that. But yeah, tattoo. So T's and A's, 2 hydrogen bonds versus C's and G's, 3 hydrogen bonds. Sounds good?